We're going to be talking about one-sided limits. And here's a graph of our function. And here is our function. F of x is equal to, this is the absolute value of x over x. We want to know what is the limit as x approaches 0, and this little minus sign right here means that we're coming in from the left of our function. And I'm saying it's equal to -1. Let's take a look at the graph. So here's 0 on the x-axis, and we're coming in from the left-hand side of 0. What you can do is pick a number to the left of 0 and either go up or go down until you find the graph, and here it is. Now, as I move my x closer and closer to 0, right, coming in from the left of 0, staying on the graph, you can see here that my y value is staying constant at -1. And so that's the reason why it's equal to -1. Now this is just by looking at a graph. We could do this numerically, plug in numbers like -0.00001 into our function, and taking a look at what the y value is going to be. But we're just going to get an idea by looking at the graph here. Okay, in this limit we're coming in from the right hand side, and so we put a little plus sign here. We say the limit of our function, which is the absolute value of x over x, as x approaches 0 from the right hand side, and I'm saying that it's equal to 1. We look back up here at the graph, and so we're coming in from the right hand side of 0, so I get to the real close to 0 on the right hand side. I either go up or down to find the graph, and there's no graph down here, so we go up, and there's the graph. So as my x value gets closer and closer to 0 from the right hand side, my y value is staying constant, and it is 1. Now, since the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right hand side, then we can conclude that the limit as x approaches 0, now you notice there's not a plus or minus here because this means we're coming in from the left and from the right. This limit doesn't exist. The limit doesn't exist because these two, the right hand limit and the left hand limit, are not equal. Let's look at this limit here. We're approaching 1 from the left of 1 over x minus 1, and I'm saying it's equal to -infinity, and then the limit as x approaches 1 from the right hand side of 1 over x minus 1 is equal to +infinity. Let's look at the graph. Okay, so here's a graph of our function, and coming in from the left hand side, so I get kind of close to the left hand side of the vertical asymptote because this is where x equals 1, and you can see that the graph is down here, and as I get closer and closer to 1 from the left, the graph just goes on down to infinity. As we can see. Now coming in from the right hand side, as I get closer and closer to 1 from the right hand side, you can see that it's going up to +infinity. So the left hand limit, we could say by describing the behavior of the graph that that limit is going to -infinity, and coming in from the right it's going to +infinity, even though the limit does not exist, because remember the limit has to be equal to a real number, but we can still describe the behavior of the graph. So once again, at looking at this, you can see that coming in from the left is -infinity, coming in from the right is +infinity, but keep in mind that our limit is really equal to a real number. This just tells us what is happening to the graph. Now, if we didn't have a graph, we could kind of do this numerically. First thing I would do is see that there's a vertical asymptote at 1 because we get 0 in the denominator, but I can take a number and plug it in that's getting real close to 1, pick something that's just less than 1, 0.999, and get the outcome. That's doing it numerically, and you would get an idea that that number is getting large, but it's negative.